What's going on, everyone? So I'm organizing a large collaborative experiment for March, possibly the equinox, and I'm looking for people who want to join in. This is an upgraded Eratosthenes experiment. Most of you already know that with just 2 measurements, the results can match either a globe with a distant sun or a flat Earth with a local sun. But once you add a 3rd measurement, the prediction for each model starts to align with only 1. So instead of 3, I want to do 5 or 6 people across different latitudes. Everyone participating will take 1 measurement, a shadow measurement, using a simple apparatus taken exactly at solar noon on the same day in March, with observers all over the US, Mexico, Canada. Now this will only work from 5 degrees north to about 54 degrees north. That's just because once you get closer to the equator, the stick gets in the way of the exact shadow measurement with this apparatus. And if we go more north than 54 degrees, I have to start making the base of this thing really long. So longitude difference doesn't matter. Between Boston and the coast of Oregon, so opposite ends of the coast, at solar noon, the altitude of the sun only changes by like 0.08 degrees in those few hours. So it's far too small to affect the outcome. Now here's the device we'll be using or replicating. It's a simple vertical pole. It's 40 inches tall. 1016 millimeters. I realized after I designed all of this that I should have just done 1 meter. I'll have 2 3D printer files. One of them is for the A1 Mini, which is 180 millimeters print plate. And then the standard one prints on a regular A1, about 250 millimeter plate. Every piece is around 240 millimeters on that. I would recommend if you have a bigger print bed, print the A1 for the A1 because it is going to be less parts. I'll have this printer file available soon. I'm just making some super small tweaks to it. If you do not have a 3D printer and you want to participate, please still fill out the form. Let me know. If there are 2 or 3 people in ideal locations, I will get you one of these. We'll send it off to you. If you don't want me to send it to you, I can send it somewhere else and then you can go pick it up. But I want people in good locations to be able to do this, and I want as many people as possible to participate. Future debunker here. So here's what it kind of looks like. These are the samples to get it to work. It puzzle pieces together with a dovetail, and it holds really well. So it's going to look like that. I would say print this in a color, because on black, with my eyes, it's kind of hard to see the line difference, and the shadow is going to make it harder to read on black. But the pole, you can print any color you want, and this just literally screws together. So it's threaded, screws together. It'll be easy. This thing cost in total, it's just over 500 grams to print the entire thing, all the way to the end. Now here's the very important part. This red leg here, don't have to color these red and gray, but this red leg here needs to point directly north, not magnetic north, but geographical north. Now there's 2 ways to get that. You can take a magnetic compass, use it and go, okay, there's north, but then you have to adjust for magnetic declination, which down in Phoenix, we have 9 degrees, which is pretty far off. So I have to point this 9 degrees off of magnetic north. Or we do true solar noon shadow, which is basically you go, oh, my solar noon is at 12:13. You just put this out at like 12:10 and you basically just keep slightly turning it until right at 12:13, the tip of this shadow falls across this thing. Now this has notches every ½ degree. And as you can see, like the closer we are to the base, the closer these notches are, and the farther we are away, the farther the notches are, just like triangles. So let's say you take a measurement and the shadow falls right here. We know that that's 60 and about 1/4 degrees, which will be fine. 60 and a half, 60 and 3/4, 61 degrees, and so on. Now, all these measurements do need to be plus or minus about a minute of your exact solar noon. If you need help finding that, I can help you. So this is dateandtime.com. This is just Phoenix. So if I'm looking at Phoenix, it says 12:23. This will give us a good rough idea, but realistically, we need your exact time. If you need help finding that, you don't mind sharing your time, your exact location, I can help you with it. But I'm about 3 minutes before this. So using your real location is going to be ideal, or wherever you're going to take this measurement from. And if you do want safety precautions, let's say I live down here and I'm going to take a measurement at, this is 33.4. I could take a little 4-mile trip and get 33.5. We're going to do to 1 decimal point. So if you don't want your exact people to know your exact latitude line, then take a 4 or 5 mile trip north or south. But I will say, even knowing your exact, let's say you lived in Gratis, New Mexico, even knowing your exact latitude line, that still falls across like Albuquerque. So it's like you're not really giving too much of your location away. Who can participate? Anyone in the US, Canada, Mexico, a lot of Central America, some of those islands, the Bahamas and whatnot, Cuba, if we want. I'll never share anybody's location. I will see the city. That is it. I just need your city to plan this thing out. But your exact latitude and longitude, I won't ask for unless you need help finding something like this. Your latitude, though, we do need like 33.1, something like that, rounded to the nearest point single decimal. Now, if you want your username hidden during this experiment, just let me know. I won't associate any latitudes with any names, but I will say, here's everybody that participated. And then here separately, here is all of the latitudes that we had. I'd love for a few flat earthers to participate in this. There are a few who have gotten an invite already, but seem to have just complained or made up some excuse that didn't make much sense. I won't call them out directly though. But someone like Chewy around the 43rd degree north would be very helpful. And anyone, flat or globe, in BC, Calgary, or Winnipeg, that would be amazing. All the measurements themselves will be shared publicly. So latitude and what the measurement was, shared publicly. Longitude will be nowhere. And then a participation list will exist, but not be associated to anything. Now, if you want to participate, send me a message on TikTok, and I'll send you a link to the form for the info, or you can scan this QR code that's here right now. Once we have observers across a good range of latitudes, I'll organize a date and then some instructions, and I'll send the link for this file. Now, it will be on my debunker maker world though. I'll be posting it probably end of day today. It'll be available for anybody. Again, if you don't have a 3D printer, just let me know. And if you're in a good location, I will try to get you one. But let's run a version of the Eratosthenes experiment that goes beyond 2 measurements and gives us enough data to compare different models directly. If you want in, just send me a message or scan the QR code and fill out that form. I'd love to have as many people as possible do this. Thanks.